Hi, this is Group 14. I am Hadi Fekrmandi with my teammates Siavash Rastkar and Ghanem Aldabbous. Will present the project 1 of robot modeling course. In the project 1, we will analyze the forward kinematics of a slider crank mechanism, and in the project 2, we will synthesize foreground mechanism with the 3 given coupler positions. In the project 1, there are 4 steps. First, position analysis, then velocity analysis, acceleration analysis, and finding the trajectory path of a given point S on the coupler link. Our inputs are the position, velocity, and acceleration of a slider, and our outputs are the position, velocity, and acceleration of the crank and coupler link. We will use our analysis based on the loop equation and its derivatives. The results of our analysis shows that in this figure, the output has been depicted based on the input as R1 for both of the closures. In this vacant area, there is no answers for the outputs as our input changed in these values. And for this figure, it is obvious that we have shown the both closures of the mechanism for 4 arbitrary R1 as inputs. For the velocity and the acceleration analysis have been carried on with a chosen R1 and the R.1 and R.1 of the project. And the analysis have been carried. And the trajectory path of the point S of the coupler link is shown in this figure. This trajectory path has been plotted using the coordinates of point S on the coupler link. And now Siavash continues with the simulation and analysis of motion.
Thank you. Okay, by doing the position, velocity, and acceleration analysis and gathering the data, we will use them, and by means of SolidWorks, we can make an animation for our slider crank mechanism. As you can see here, by changing our input R1 from its minimum to maximum value, we can animate the motion of the mechanism. One of the practical applications of this mechanism is to adjust the height of the beds in hospitals. As you can see here, if we put a ball screw or actuator on the slider of the mechanism, by moving that, we can adjust the height of the top part of the bed. In our second project, we are going to design a forward mechanism by using 3 given positions for the coupler link. As you can see here in this table, 3 positions of coupler link is given, and by using them, we are going to find the pole positions and the link links of our forward mechanism. My friend Ghanem will explain it for you.
As you can see in this plotted data figure, we found the link lengths and the pole positions. The pole positions are A star and B star, which are the center of the circle. As you can see, A star is the center of the smaller circle, and the path goes from A1 to A2 to A3. And the bigger circle is B star, and the path shows that it is going to go through B1, B2, and B3. This is the figure of the continuity of motion, and the output is θ2, which shows how smooth are the waves, which means that there is no lockups or singularity of the motion system. Now this animation, which we use SolidWorks to do, shows the coupler link position going from position 1 to position 2, and from there after we go from 2 to position 3. To conclude, and this is the end, this is to feed the purpose of learning kinematics of mechanisms, especially the slider crank system and the synthesis of the forebar, which opens our minds to how to understand the engineering of robotics background, achieving teamwork goal where all engineers cooperate, seeking the solutions to figure all inputs and outputs, yet for building a system that fits the requirements. And thank you for listening.